We want to determine dy dx and the second derivative of y with respect to x, given x equals 3 cosine 2t and y equals 6 cosine t. Then determine the open intervals within the interval from 0 to pi, where the curve is concave down. Because we have parametric equations, recall that dy dx equals dy dt divided by dx dt. Starting with the numerator, derivative of y with respect to t equals the derivative of 6 cosine t with respect to t, which is 6 times negative sine t, or negative 6 sine t. And for the denominator, dx dt equals the derivative of 3 cosine 2t with respect to t, which requires a chain rule. The derivative is 3 times negative sine 2t times the derivative of 2t, which is 2, which gives us negative 3 sine 2t times 2, which equals negative 6 sine t, all divided by negative 6 sine 2t. Before we simplify negative 6 divided by itself, let's perform a substitution for sine 2t. Recall sine 2t equals 2 sine t times cosine t. This gives us the quotient negative 6 sine t divided by negative 6 times 2 sine t cosine t. And now we'll simplify. Negative 6 divided by itself simplifies to 1, and so does sine t divided by sine t. dy dx is equal to 1 divided by 2 cosine t. And because 1 divided by cosine t equals secant t, we can write dy dx as 1/2 secant t. And now let's determine the second derivative of y with respect to x. Looking at our notes, which equals the derivative of dy dx with respect to x, which equals the derivative of dy dx with respect to t divided by dx dt. The derivative of dy dx with respect to t equals the derivative of 1/2 secant t with respect to t, which is 1/2 times secant t tangent t. And this is divided by dx dt, which we found above. Recall dx dt is a derivative of 3 cosine 2t, which we can see here is negative 3 sine 2t times 2, or negative 6 sine 2t, or if we want, negative 12 sine t cosine t. Let's use negative 12 sine t cosine t. And now let's simplify this quotient by multiplying the numerator by the reciprocal of the denominator and also converting to sines and cosines. For the numerator, secant t equals 1 divided by cosine t, and tangent t equals sine t divided by cosine t. Let's write the numerator as 1/2 times 1 divided by cosine t times sine t divided by cosine t. And then instead of dividing by negative 12 sine t cosine t, we will multiply by the reciprocal, which is 1 divided by negative 12 sine t cosine t. And now let's simplify. Sine t divided by sine t simplifies to 1. Nothing else simplifies. We have 1 divided by negative 24 cosine cubed t. If we want negative 1 divided by 24 cosine cubed t. Let's continue on the next slide. Because 1 divided by cosine t equals secant t, we can write the second derivative as negative 1/24 times secant cubed t. So again, going back to our first slide, we found the first derivative, and now we have the second derivative. And now for the last part of the question, we want to determine the open intervals within the closed interval from 0 to pi, where the curve is concave down. Recall the curve will be concave down when the second derivative of y with respect to x is negative or less than 0. Looking at the second derivative, let's actually look at the second derivative where we have the cosine function, notice this quotient is going to be negative where the cosine function value is positive. Looking at the graph of the cosine function at the right, we should remember the cosine function is going to be positive over the open interval from 0 to pi divided by 2 radians, which means over this interval, the cosine function value is positive, and therefore the second derivative will be negative, and the curve will be concave down. So we'll say the curve is concave down on the open interval from 0 to pi divided by 2 within the closed interval from 0 to pi radians. Before we go, let's verify this by analyzing the graph of the curve. I've already set this up in Desmos. To graph the parametric curve, I entered 3 cosine 2t, 6 cosine t as an ordered pair. To animate a point on the curve, I have the same entry but used a so that I could create the slider for a. And notice the slider for a goes from 0 to pi radians. And notice from 0 to pi divided by 2 radians, as we animate the point, this half of the curve is concave down. And then after pi divided by 2 radians, you can see the red curve is concave up. So it is correct, the curve is concave down over the open interval from 0 to pi divided by 2 radians. I hope you found this helpful.